In quantum mechanics, three key conceptual innovations have not only shattered the tenets of the old physical worldview but also unexpectedly align with Buddhist concepts. These pivotal ideas, objectivity, reality, and independence, and their reconstruction by quantum mechanics undoubtedly pose a major challenge. Even a subversion to the logical framework of traditional physics and the scientific notions held by people. No amount of time spent discussing them would be excessive. Moreover, these three transformations correspond to a re-understanding of the mind-matter relationship, the thing in itself, and the relationship between things. Hence, these three concepts also form the foundation upon which we humans build our worldview and philosophy of life. Coincidentally, they were the three main pillars on which the Buddhist philosophical system was established more than 2,000 years ago. And they are precisely the theoretical propositions that the major Buddhist schools, Yogacara, Madhyamaka, Tathagatagarbha, Huayan, and Tiantai, have studied and elaborated for over a millennium. Concepts that originally, in the era of old physics, were completely at odds with religious thought have, after new internal transformations, become an important basis for dialogue with Buddhism. For Buddhism, which had already formulated complete ideas in ancient times, dialogue is merely a form. What matters more is that it endows the thousand-year-old Buddhist thought with a new unfolding in the modern age. In the following content, we will discuss these three concepts in depth, exploring how science and Buddhism have moved from being completely incompatible to gradually sharing common ground. First, we discuss the concept of objectivity. 1. Modern physics, the revolution of objectivity. The existence of an objective world is not only a central tenet of the development of physical science but also the main spiritual hallmark of science. As Einstein and Infeld said, without the belief that the theoretical structures of science can grasp objective reality, there would be no science. In that era, scientists firmly believed that this conviction was the fundamental motive for all scientific creation. However, this central tenet and spiritual hallmark were shaken by the very conclusions of science itself as modern physics advanced further. This revolutionary development is one of the many impacts brought by quantum physics. And it still begins with the paradoxical phenomenon of wave-particle duality. In the photoelectric effect, when light of a certain intensity strikes a metal surface for a period of time, the metal emits electrons, called photoelectrons. The number of photoelectrons emitted per unit area per unit time is independent of the frequency of the incident light, but is proportional to the intensity of the incident light, and light intensity is proportional to the number of photons. That is, light behaves as if it were particles knocking out electrons. In the double-slit experiment, light passing through two slits produces an interference pattern on a far wall, which is a manifestation of wave behavior. These two contradictory behaviors have been successively proven to be possessed by photons, electrons, and even macroscopic matter. Under different experimental setups, different behaviors appear, but the two never appear simultaneously in the same experimental observation. Schrödinger developed wave equations from the wave aspect of microscopic particles, while Heisenberg developed matrix mechanics from the particle aspect. The two were later proven equivalent, indicating that wave-particle duality is indeed a property of microscopic particles. The descriptions derived from two different methods of observation are actually consistent. However, the question of how these two contradictory properties can coexist was resolved by the complementarity principle after the concept of uncertainty was proposed. The wavelength and energy of the light used to observe a microscopic particle inevitably disturb the position or momentum of the observed particle. Long wavelength, low energy light cannot accurately determine the position of the particle. Short wavelength, high energy light disturbs the accuracy of the particle's position. Clearly, the position and momentum of a particle cannot both be accurately measured at the same time. Thus, the revelation of uncertainty triggered various interpretations among physicists. Both Einstein and Planck believed that the uncertainty of quantum theory was due to the inadequacy of our current knowledge. Consequently, David Bohm proposed that the missing part was hidden variables not yet perceived, so-called hidden variables, but this idea has not been accepted. Others said uncertainty arises from the measurement process and is a limitation of the experiment. Or that it is a limitation of human concepts. We can never know whether an atom itself is determinate or indeterminate. Or, as Heisenberg argued, uncertainty is an objective characteristic of nature, not a limitation of human knowledge. That is, an electron does not always possess precise properties such as position and velocity. However, the orthodox interpretation that eventually gained general acceptance is Bohr's idea that these uncertain elements together form a complementary interpretive mechanism. Wave-like and particle-like properties, position and momentum that cannot be simultaneously measured. And other such mutually exclusive yet conjugate properties belonging to the same microscopic particle, complement each other's deficiencies, allowing a broader interpretation of microscopic particles and bringing us closer to their true nature. Regardless of where the uncertainty comes from, the complementarity interpretation offers a solution for dealing with uncertainty. On the other hand, uncertainty and complementarity reveal that we cannot know the true state of affairs, a fact that cannot be ignored. When the observation system is set up as a double-slit experiment, wave behavior is observed. When it is set up as a photoelectric effect, particle behavior is observed. When observing a particle with long wavelength light, the obtained position is imprecise. With short wavelength light, the true velocity cannot be measured. Clearly, the properties manifested by the observed object are determined by the observational system. By extension, perhaps some properties of matter remain unknown simply because we have not or do not know how to set the observational system to a certain state. This is why Heisenberg said, "What we observe is not nature itself, but nature as revealed by our methods of questioning." Whether it is the observational system or the method of questioning, both are products of human consciousness. They are ways of conducting measurements determined by the observer's background knowledge and experience. To some extent, these decisions also determine the properties of the observed object. Thus, the scientist's concept of objectivity suddenly awakened amid the discovery of the interaction between object and observer. According to Bohr's complementarity principle, reality is not dualistic but the result of experimental interaction. As Capra said, the properties of an object have meaning only in the context of the object's interaction with the observer. Even using so-called objective scientific methods, the world we perceive is still the result of our subjective interaction with it. It is even possible that we ourselves create the appearance of this world. The truth of the so-called objective world thus becomes unknowable, if we believe that an objective world indeed exists. Hence, in the quantum world, we can only infer the probabilities of various possible events actually occurring. Only when an observer makes an observation does one, and only one, of the many possibilities become actual and appear before us. To illustrate a concept so different from classical physics, Schrödinger, who discovered the wave equation, proposed a famous thought experiment, Schrödinger's cat. The idea: in a closed box, there is a live cat and a bottle of poison. If the cat eats the poison, it will die. By common sense, the cat may eat the poison and die, or not eat it and live. Only these two outcomes are possible. According to classical physics, the cat is either dead or alive, and opening the box reveals the result. But quantum mechanics tells us that before observation, there is an intermediate state. The cat is neither dead nor alive. Both outcomes are possible. Only when we open the box do we know the actual result. That is, classical physics holds that things exist objectively. Before we observe, the outcome is already settled, and we merely discover the world. quantum physics, however, says that things only take on form and outcome because we observe them, and a particular result appears according to our observational conditions. In a sense, we do not discover but rather create the world. The observer in quantum physics has become a participant, even a decider in the exploration of the world. One might say more directly that the scientist's consciousness draws the blueprint of the physical world. If we infer from this, physics has not overthrown its own foundation but rather discovered its true basis, and has begun to extend in a new direction, building a bridge to begin communicating with the aspect it had long rejected, consciousness. The search for an actual model of reality drives theoretical physicists to study philosophy or to subscribe to a particular religion. 2. Buddhism, all dharmas are only consciousness, and the three realms are only mind. The idea that consciousness constructs this world is one of the main tenets of Mahayana Buddhism. The Dharma characteristic school, Foshyang/Yogacara, viewing from the perspective of all phenomena, states that all dharmas are only consciousness, Vijnapti Matra. The Dharma nature schools, Faxing, such as Huayan and Tian Tai, speaking from the essence, assert that the three realms are only mind, Siddhamatra. In the discourse of the Dharma characteristic school, the functions of mind are divided into 8 consciousnesses. The first 5 consciousnesses, through the 5 sense faculties, eyes, ears, nose, tongue, body, perceive the existence of external material objects but do not judge them. The 6th consciousness, the mental consciousness, truly discriminates what is perceived, evaluates likes and dislikes, and engages in various deliberations. The 7th consciousness, manas, clings to a self, while the 8th consciousness, alayavijnana, stores the seeds of all dharmas and has the functions of being perfumed and manifesting, producing actualities. That is, everything from the first 7 consciousnesses to all phenomena in the universe. Everything we can perceive is actually the manifestation of seeds in the alaya field. It is merely a function of consciousness. To combine the ideas, a person's past experiences, feelings, and thoughts continuously accumulate into a composite that unconsciously influences present and future perceptions of external things. When facing external things, the first 5 consciousnesses' cognition of objects depends on the manifestation of consciousness seeds and the functions of the 5 sense faculties, plus the 6th consciousness's discriminatory evaluations. This includes past experiences and feelings, part of the seed manifestation, and newly arising discriminative thoughts. Thus, given the same external environment, due to differences in each person's 6 faculties, seeds, and sensations, more precisely, differences in the 6 consciousnesses, what different observers perceive will inevitably differ in degree. Under this reasoning, the observing mind consciousness influences and even determines the observed realm. Subject and object condition each other. Everything in the universe is actually the result of the discriminating function of consciousness. There is no objective standard. This is what the Mahayana Secret Revelation Sutra, Ganavyuha Sutra, says. Sentient beings and vases, all sorts of forms, though internal and external differ, all arise from mind. Where mind consciousness operates, there are all realms, though what is seen differs, there is only consciousness, no objects. Vases, clothes, and other things, all objects are absent. Mind changes and produces semblances of realms, giving rise to grahaka, grasping subject, and graya, grasped object. On the other hand, the Dharma nature schools explain the formation of all things in the world as stated in the Avatasaka Sutra. The 3 realms are illusory, only made by mind. The mind is like a skilled painter who paints all worlds, the 5 aggregates all arise from it, and no Dharma is not created. The mind creates the entire world just as a painter paints a picture. The myriad things in the universe are established by the mind's discriminations and thoughts. Hence, all things in the world are functions of the mind. The mind spoken of here refers to the naturally pure mind of the Tathagatagarbha. Due to the arising of ignorance, avidya, various worldly appearances are evoked. Each appearance is a transformation of the Tathagatagarbha. As wind blowing over the great sea gives rise to various waves, the wind of ignorance blows over the sea of Tathagatagarbha, causing dharmas to stand apart like various waves. The sea changes, but only in appearance. Each wave is still seawater. Tiantais, 3000 realms in a single thought, says that within a single moment of thought, all forms of dharmas in the world are fully present, good and evil together. The awakening of Mahayana faith speaks of one thought of ignorance giving rise to 3 subtle and 6 coarse aspects. And all realms in the world abide based on sentient beings' delusive ignorant minds. The delusive ignorant mind is actually the Sasra gate, the door of arising and ceasing. One of the 2 gates opened by the Tathagatagarbha mind, which can establish all dharmas. This explains the principle of everything is created by mind alone, from the perspective of the essence of things. If we discuss the principle that Tathagatagarbha is identical to Aliyavijnana, then the idea is that the 3 realms are only mind, and all dharmas are only consciousness, are not 2 different meanings. 3. Dialogue. 1. Mind and matter are interrelated. From this perspective, physics starts from the domain of a matter, and Buddhism starts from the domain of a mind. Yet both arrive at a similar conclusion, affirming the influence of spirit on the material level. Of course, modern physics has not yet explored the role of consciousness in the investigation of the world as deeply as Buddhism has. Nor do we find concepts similar to Aliyavijnana, seeds, Tathagatagarbha, etc. It would be premature to say the 2 conclusions are entirely the same. Moreover, Buddhism concludes that all dharmas are illusory and unreal because matter manifests as consciousness. Most physicists would likely acknowledge the decisive role of mind on material objects, but would not fully agree with the rejection of the reality of matter. Nevertheless, it is certain that their reorientation of the roles of mind and matter and the confirmation of consciousness's influence on the objectivity of the world indeed align with the Buddhist doctrines of mind only and consciousness only. Especially the Yogacara explanation of the discrimination of the conscious mind. Clearly, when physics speaks of consciousness interfering in determining the world we observe, its consciousness seems closer to the discriminating mind. Physics has discovered that no matter what observational system is used, it inevitably disturbs and affects the observed object. No matter how complex our instruments, how sophisticated our theories and calculations, it is still our consciousness that ultimately interprets our observations. Our different understandings of the same phenomenon depend on how we observe and the concepts we project onto the phenomenon under consideration. As Pearson metaphorically put it, we are shut up and limited in this world of sensory impressions, just as a telephone operator is shut up and limited in his world of sounds. Our world is also conditioned by our nervous systems and our sense organs. It is the similarity of the sense and perceptive faculties of all normal human beings that makes the external world the same, or practically the same. For all of them, we project any group of immediate sensory impressions outside ourselves and regard it as part of the external world. We call it a phenomenon and say it is real in practical life. Thus what we call the real world is based partly on immediate sensory impressions and partly on stored sensory impressions. Eddington also regarded the world of physical science as nothing but an abstract symbolic world. A shadow world abstracted from measurable things extracted from human sensory experience. That is, Eddington also believed that the so-called physical world is merely a mental construction, inseparable from subjective conscious thought. This is indeed close to the Buddhist position of all dharmas are only consciousness. we can say that physicists have concluded that consciousness necessarily influences material observation. That is, objects cannot be completely independent of the mind. The observing mind and the observed realm condition each other, and the two cannot be discussed in isolation. This view is consistent with Buddhism. Buddhism can further explain that at the moment of observation, the conscious mind not only cognizes the existence of material entities but also, based on past experiences, seeds, deliberates and discriminates. These form an overall cognitive impression. But it is no longer the original naive perception of the object itself. Hence, the cognition obtained cannot be the true appearance of things. In other words, the results we obtain from observing the objective world, whether with our own senses of sound, smell, color, taste, touch, or with scientific instruments, are all illusions. They all deviate from the objective world. This explanation closely resembles a deduction made by scientists in The Ghost in the Atom. It seems that when the experimenter just observes the measurement result, the changed mental state somehow feeds back to the laboratory apparatus, and thus back to the quantum system, which also changes its mental state, and the mental state in turn reacts on the physical state. Heisenberg, with his uncertainty principle, further demonstrated that in the microscopic world, the object is greatly disturbed by the measurement process. The objective mass of a particle cannot be accurately measured. He regarded microscopic particles as simple representations of the basic mathematical structure reached when trying to divide matter. Reminiscent of the Buddhist saying, "The ultimate particle has no reality, it is only forcefully named, Mahaprajnaparamita Sastra Chapter 12. In other words, the Buddhist view that there is only consciousness, no objects, appears in a different expression in physics. What we observe is only the result of interaction between ourselves and the observed object. The mechanical picture of all physical systems thus is considered unreal." Alistair Ray, in his book Quantum Physics, Illusion or Reality, writes, "Since the beginning of modern science 400 or 500 years ago, scientific thought has seemed to move human beings and consciousness far away from the center of the world. Yet now we find that physics, formerly considered the most objective of all sciences, is reacquiring the human soul and placing it at the center of our understanding of the universe. Clearly, when physics develops to the depth of quantum mechanics, it reveals exactly what Buddhism has long maintained: a world blueprint dominated by consciousness." 2. After the discovery of consciousness, physicists discovered the disturbing influence of consciousness not deliberately but through conflicts arising from the study of matter itself. This is completely different from Buddhism's dedicated study of consciousness. Naturally, they would not, as Buddhism does, engage in efforts like, when the mind is pure, the land is pure, or turning consciousness into wisdom. Scientists believe that, by means of the quantum uncertainty principle, spirit finds its expression in the world. However, science is an impersonal, objective enterprise. The idea that the observer is a key element of physical reality seems to contradict the entire scientific spirit. Clearly, this inadvertent discovery has placed physics in a dilemma. Hence, some argue that the necessity of introducing consciousness for interpretation is simply a limitation of knowledge or experiments. Perhaps as science advances beyond these limitations, the objective world will still be attainable. This insistence on the existence of an objective world, in actual reality, is not found in Buddhism. In Buddhist understanding, there is absolutely nothing in the human environment that exists independently of the mind consciousness. To some extent, one might say that the theoretical elaborations and various methods in Buddhism also aim toward a kind of objective world. But this objective world is by no means the early physics' materialistic, mind-denying world. Instead, it is mind-only, matter-denying, or mind and matter as one. Because once the interference of consciousness is removed, all things that are products of consciousness necessarily vanish. The disappearance of things is not a phenomenal elimination but a mental non-disturbance. What remains is the original pure principle body, the Tathagatagarbha, which is the so-called nervous state, the ultimate pure state of mind, the ultimate goal of Buddhist practice. Of course, Buddhism does not reject this unreal, material world we face. The various studies and creations of matter by physicists, as long as they are based on correct intentions, benefit others without harming them, are still affirmed in Buddhism as wholesome dharmas that accord with the conventional world. That is, before we can escape consciousness's interference with the world, we should understand the role mind plays in the human world, thereby adopting a correct attitude and understanding toward the material world, and further making substantially beneficial and positive improvements. This is a kind of wholesome dharma at the level of conventional truth, illusory view, called Savti Satya, conventional truth. Similar ideas appear in the views of some physicists. They hold that matter is inevitably influenced by spiritual factors, the objective world is originally unknowable. Bohr, for instance, actively proposed that in our descriptions of nature, the aim is not to reveal the true essence of phenomena but to trace, as far as possible, the relationships between different aspects of our experience. Interpreting Bohr's meaning. By exploring different aspects, even if based on non-original cognition mixed with consciousness, we can still, through mutual complementarity, more clearly understand this illusory world and then take positive actions. After all, we live in this illusory world constructed by consciousness. Thus, this obviously aligns with the Buddhist concept of conventional truth mentioned earlier. Moreover, since interference by consciousness is inevitable, why not skillfully use this interference to guide it toward influences with positive developmental significance? Perhaps this could provide a positive source of inspiration for the physics community, which is just beginning to understand the mind-matter relationship, as it faces the collapse of old foundations. This, too, would be one of the positive significances of dialogue between quantum mechanics and Buddhism.